Hello everyone, I am Omkar Gupta and along with me Ravikumar Gupta. Today we are presenting our research paper review on bootstrapping in compiler design, which is based on Andrew Appel paper, which is axiomatic bootstrapping, a guide for compiler hacker. Now, let us understand first what is a bootstrapping. Bootstrapping is a fundamental concept in compiler engineering because it allows compiler to eventually build themselves, making a model compiler development more efficient and scalable. First, let us understand what compiler bootstrapping means. A compiler translates source code into machine code. Bootstrapping means writing a compiler in the same language that it is designed to compile. For example, a C compiler written in C is a bootstrapping compiler. This makes compiler self-hosting easier to upgrade and portable across system. This creates an important question. If a compiler is written its in own language, how was the first version created? These challenges motivate Andrew Appel research. This paper explains how self-compilation works in formal and structured way, removing confusion from the process. The main goal of Apple paper is to provide logical framework for compiler bootstrapping. He introduced an axiomatic model, a set of formal rules that explain how compilers generate and compile new versions of themselves. This making compiler design mathematically precise and verifiable. A major challenge in bootstrapping is the chicken and egg problem. If a compiler is written in language X, we need a compiler for X to build it. But if none exists yet, how do we start? Apple solved this using stage bootstrapping. First creating a simple compiler in another languages, then gradually building the final self-hosting compiler. This is the core contribution of the paper. Apple defined axioms that describe how compiler input, output, and machine interaction work. These rules act like mathematical laws, allowing compiler transformation to be logical proven correct instead of assumed. These give the paper strong theoretical importance. The bootstrapping process happened in stage. First, a primitive compiler is built in another languages. Next, it's compiled the target compiler source code. Then the generate compiler recompile itself and become a self-hosting. At this point, it's become independent and ready for the future upgrade. Now I would like hand over to Ravi for the remaining part of presentation. Thank you.
Thank you, Omkar. My name is Ravikumar Gupta. Now I will be continue with the T-diagram representation. T-diagrams are visual method using compiler design to represent how compiler operate. They show source language, target language, implementation machine. These diagrams make it easier to understand translation chains between systems. They are especially useful in cross compilation and multi-stage bootstrapping. One major insight from this paper is that bootstrapping can be formally proven. Appeal demonstrate that compiler states are logically derived. He also shows that the cross-machine compilation become easier when modeled through exams. The transforms compiler designs into more rigorous and scientific disciplines. These ideas are not limited to theory. Modern compilers like GCC, LLVM, Rust compiler, and Java JDK also use bootstrapping. This allows them to improve themselves, update efficiently, and run across multiple platforms. So, appeal theory has directly real world impact. Advantage and limitations. Bootstrapping offers major advantage. It enables self-hosting, portability, and easier long-term maintenance. However, there are also limitations. Initial setups is difficult. Debugging recursive compilers error is challenging, and hardware dependency can complicate portability. Critical analysis. In our analysis, the great strength of the paper is clarity. Appeal take a difficult topic and make it logical, understandable. Even decade later, his framework remained highly relevant. That shows the last value of research. Conclusion. To conclude, the bootstrapping is essential for modern compiler development. Andrew Appeal paper give a formal mathematical explanation that strengthens both theory and practice. It remained one of the foundation work in compiler design. References. The main reference for the presentation is Andrew W. Appeal, original ACM top class paper from 1994. We also refer to Princeton Research Archives and Compiler Design textbook. Thank you for everyone.